All right, welcome to lesson 2.2. You can totally work with a partner on this. First thing I want you to think about is what did we figure out in lesson 2.1 with the endoscopy reports? Do we know what is wrong with McKenna or how it could be impacting her? And what do you think happens to McKenna's food when it gets to her small intestine? So, if we think about what we saw in those endoscopy reports, there was really something different about her small intestine, right? So, take a moment, chat about these ideas with your partner. So, what exactly happens to our food when it's in our digestive system? Following the food through the small intestine is another way we might be able to figure out what exactly is going on. Data from different food samples in McKenna's case were compiled in the form of graphs that show some information about what happens to food in the small intestine. And these graphs are in your lesson 2 packet. So, following our food molecules through the digestive system, we have estimates of the average percentage of breakdown of food molecules in a graham cracker. So this is someone eating a graham cracker and then looking at the different food molecules of the cracker as it passes through the digestive system. And we have this amount for both the healthy person and for McKenna. The relative amounts of each substance is shown in graph form. And you should look to see if there are any patterns that seem to indicate that one substance is increasing while another is decreasing at the same rate. So we're going to use our I-squared strategy. So this is identify and interpret. So we identify by putting what I see, and we interpret by saying what it means. All right, so we'll use the identify and interpret strategy to help us analyze graphs of food, as it enters and reaches the middle of the small intestine. The next step in our I-squared strategy is to come up with our interpretation. So, what it means. So, we're tackling that same question. What happens to a graham cracker as it passes through McKenna's small intestine versus a healthy person's? So, we're going to interpret the what I see or the observations that you made. So, look at each what I see and think, what's the explanation for this? And then you're going to write what it means, or WIM, and then add an explanation next to your observation. So let's go through some examples of this. We'll start with a what I see. We're going to be looking at both graphs. I know they're on 2 separate pages, but we do want to look at both graphs for this. So here's some example what I see. So first off, if we look at water, so the water bars, the green is the healthy person or the top bar. The orange is the bottom bar, and that's McKenna. So we have healthy person and McKenna. If I look at healthy person and McKenna for the beginning and for the middle of the small intestine, I can make the note, what I see, write it right on your paper, what I see, healthy, meaning the healthy person, and McKenna have equal amounts of water present. So there's water present in the beginning and in the middle, and they both have the same amounts. That's an observation. Another observation, certain molecules are grouped together. So you can see I have this box around different molecules. So glucose, complex carbohydrates, fiber are boxed together. Fatty acids and fat are boxed together. Amino acids and protein are boxed together. Water is not in a box. That's going to be important. And then the last what I see that I could put is the healthy small intestine shows a large decrease in glucose from the beginning to the middle. So the green bar, very high, then very low. McKenna does not show that decrease. She has pretty high glucose and it's still high. So that's another what I see. So pause and make notes on your graph. All right, now let's do the what it means. So this is our interpretation piece. So The healthy and McKenna have equal amounts of water present. A possible explanation would be that McKenna's problem does not involve the water in her small intestine. There doesn't seem to be a difference. So that is probably not where her health problems come from. For why our molecules are grouped together, they must be directly related to each other. For why I see this decrease in our healthy small intestine for glucose, but not a decrease for McKenna. This is important. This tells us, or this could mean, there's a little typo that should say WIM, what it means. I apologize. McKenna's small intestine is not dealing with glucose the same way a healthy person's does. So this is a key piece of evidence for us. All right, I want you to take a moment and give me at least two more what I see, what it means on your graphs. So pause and do that right now. What I see, what it means. And then we're going to come back. So pause right now, two more. So what does happen to a graham cracker as it passes through McKenna's small intestine versus a healthy person? It seems like a healthy person is showing a change in the amount of amino acids, the amount of proteins, and in the amount of glucose and complex carbohydrates for a healthy person. McKenna's, those molecules do not seem to be decreasing or disappearing like they are for a healthy person. Those molecules are staying in her small intestine. So that seems like it might be where her problem is. All right, time to grab those progress trackers. So grab your progress tracker, and I want you to find lesson 2 and think about what you figured out, right? We already have the question there. What are some of the things you figured out? So let's think about some of the big ideas that we've learned about in both part 1 and part 2 of this lesson. First, we figured out that the digestive system is made up of parts called organs, right? See if you can list the organs of the digestive system in your progress tracker. What part of McKenna's small intestine looked different? Include a description of McKenna's small intestine and how it's different. And then, last but not least, how did McKenna's small intestine seem different when it came to the types of molecules that either stayed in or left? You got this.